Hello, this is Joseph Alexander Van Zandt. Today I will be doing a series of exponential equations using a computer program I wrote. I would like to say something. I attempted to use logarithms to solve these types of exponential equations. And what I got when I put in the calculator was not the right answer. For example, if you use the first problem I will do will be 2 raised to the power of x plus 8 raised to the power of x equals 130. When I did that, I got a number close to the right. I believe it's 2.3 something. But if you actually put that in the equation, you got 209 between between 209 and 210. That's not the right answer. The right answer is 130. So this computer program which I wrote, I would demonstrate, and this is a fairly straightforward computer program. I wrote it. I'm sure other people could write it. Many people have noted that logarithm equations, in terms of exponential equations, you don't get the right answer. In my opinion, certainly, if you go back to Babylon, there are some archaeologists who went there, and logarithm equations are mentioned there, but they're mentioned for base 12 mathematics. In other words, our number system has 10 numbers in it. Base 12 mathematics has 12 numbers. You would have 2 additional numbers. Well, you would have, we have 9 digits. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would have an independent number for 10 and an independent number for 11. If you do those types of calculations, and sometimes in physics, things come out evenly there. Logarithms, in my opinion, were meant to tie into those types of calculations which you see in ancient Babylon. In ancient Babylon, and several other ancient places, you see extraterrestrials, or people with, like, birdmen, people with beaks on them, and people that do not appear to be human. Some have tails, some have beaks, and those people or those extraterrestrials have 6 fingers. If you have 6 fingers, you may have base 12 mathematics. Most humans have 10 fingers, and we have base 10 mathematics. In my opinion, certainly, the people of Babylon have contact with extraterrestrials. And there are pictures of extraterrestrials there. You see pictures of extraterrestrials in Egypt in hieroglyphics, and sometimes you can count their fingers and sometimes you can't. But in any case, I have this logarithm equations, and I will use this to, this is a demonstration of it, and it could be used to confirm if you have the right answer in this type of exponential equation. Let me show you. I'll just copy it here. The minimum value in this 2. The minimum value is 2. The reason is because if you add both sides, you have 10. And if you take 10 and you square it, you get 100. You take 10 and you cube it, and you get 1,000. So 130 is between 100 and 1,000. So I'm going to put in 2 is the minimum value. The maximum value is 3. It's between 2 and 3. Increments you're going to use, I'm going to put 0, 0, 0, 0. The more increments you use, the more accurate it is. Okay, x is equal to 130. And x is raised. Okay, so the coefficient is 10. Okay, so it's starting to do its calculations. Basically, it's starting at 2, and it's going at 0.0001. In other words, a point and 4 zeros and a 1. It's going forward. I will confirm the calculations with a graphics calculator. Did you see? In other words, the program, this computer program, is taking, it's starting at 2. It's increasing by 2.4 zeros and a 1, and it's getting an answer. Okay, so it has the total coefficient value. So correct. So what the program is saying is, if you take 10 and you raise it to the power of 2.11394, you're going to get 129.998997, which is very close to 130. Let me do that in my graphics calculator here and see what I get. See if I get 130, just to confirm it. So if you take 10 and you raise it to 2.11394, you get 120. Well, this is 129.999. Correct, which is it's just rounding up, but it's very close to the answer. So this is one way. This is a computer program, but this computer program could solve any basically any type of exponential equation. Let me demonstrate with another one. Let me just close it and go to another one. 1 moment. Okay, I'm going to put this in again, and I have the number that I wrote out here was 15 raised to the x. Let's do that. We're going to put in 15. Okay. 15. To the x equals 275. The minimum value. So the minimum value is 2. The maximum value is 3. Increments would be 0.00001. Enter coefficient. What equals 275. Here's the coefficient value. So it's going to get an answer. It's doing these, it's increasing 0.0001. Okay, so the value it comes up with is the total coefficient value it has is 274.99852. The original value was 275, so that's very close. And it has so 15 raised to 2.0741 equals 274.99852. And let me do that with my calculator to see if it's correct. So if you get 15 and you raise it to 2.077 7. You get 2.74.99, which is very close to 275. Okay. This is Joseph Alexander Van Zandt. Thank you for listening for my way of solving exponential equations and confirming what you get with logarithms is correct or is not correct. I appreciate you listening. Good day.